Welcome, GeoTrig. This is 5-5, Trigonometric Equations. The essential question is, what is a trigonometric equation, and how many solutions does it have? Let's roll. Well, what is that? A trig equation is an equation that uses trig functions with variables. So sine of x equals 1. It's got an equal sign, and it's got a trig function, sine of x. Now this one got a sine of 0 equals 0. Well, yeah, that's true, but there's no variables in there. It's not a function. If I just wrote sine of x, that's also not a function because there's no equal sign. You need an equal sign for an equations. So the values that satisfy or solve an equation are its solutions. There are trig equations that can have no solution. You can have no solution. There you can have more than one solution. So for example, sine of x equals 1. Well, sine's all the y values, and y values are at 1 if you take your unit circle. It happens right here at the top. So x is going to be pi over 2. But wait. It's not just the unit circle. It could also be, you go around more than once, the coterminal angles. It could be 5 pi over 2. Right? And you could actually go the opposite direction, and it could be negative 3 pi over 2. And we got a lot more than that. So you can have more than one solution. Now, what if you tried sine of x equals 2? Well, on a unit circle, it's only going to go out 1 at most. This has no solutions. It will never equal 2 because the range of the values is from -1 to +1. So 2 is too high. All right. So an equation includes multiple angles. The period of the function always plays an important role in ensuring that we do not leave out any solutions. So for example, if I want to find sine of x equals 1/2, and this is the graph of that sine function. So this has like a few periods right here. So 1/2 happens at this dot and this dot. So at pi over 6, so x that happens, this is the y values here, that happens at pi over 6, and it happens at 5 pi over 6. That's like on the unit circle. But it also happens at other points. It happens at 13 pi over 6, 17 pi over 6, and -7 pi over 6. Because this function goes to left and right forever, there are an infinite number of solutions. But we might need some way to represent every one of these solutions. And here's how we do this. So you want to find, first step here, 2 steps. You want to find all the solutions that are within the one period. So basically the unit circle, from 0 to 2 pi. This bracket means you include 0. The curved bracket here means you include everything up to 2 pi, but not including 2 pi because it's the same as 0. So anyways, our 2 solutions were x equals pi over 6 and x equals 5 pi over 6. All right, so now for each of these solutions, any multiple of 2 pi can be added to the solution. So it means 2 pi, 4 pi, 6 pi, and then -2 pi. So it's multiples. The way we represent that is we use n as an integer to represent a multiple. So the formula, instead of saying x equals pi over 6, it's pi over 6 plus 2n pi, where n is some integer. So n is an integer. So n integer, positive or negative. So if n was 0, it'd be just pi over 6 plus 0, so just pi over 6. But if n was 1, it'd be pi over 6 plus 2 pi, which would get 13 pi over 6. Same thing over here. X equals 5 pi over 6, I'm adding 2n pi. And these are all in radians. If you want to do degrees, you can add 360n would be degrees. But let's stick with radians. So let's do this problem. Solve this equation. My first step, I want to isolate these trigs. I don't like it on both sides. So I'm going to subtract 3 sine of x on both sides. So -3 sine of x. What happens here is you get a cancel on the right. And so you get 2 sine of x equals radical 3. Now I want to isolate this sine of x. So I'm going to divide by 2 on both sides. Cancel. So you have your sine of x equals square root of 3 over 2. Okay, so we got our trig function isolated right here. Now, if we're following those last steps, I got to find all my solutions within one period. So my solutions for this x, 3 pi over 2, I like drawing my unit circle for this. These are your y values. So these are going to happen right here and right here. So these 2 dots. And that's going to be at 60 degrees. And this is going to be at 120 degrees. And another way to do that in radians here, this is going to be pi over 3. And this is going to be 2 pi over 3. So my 2 solutions are going to be x equals pi over 3 and x equals 2 pi over 3. But we have an infinite number of solutions, so we just have to add the extra 2 pi at the end. So pi over 3 plus 2 messed up on me. 2n pi. And x equals 2 pi over 3 plus 2n pi. So these are my solutions. That'll cover everything that will satisfy that equation. All right, let's try this one. So here's the difference here. This is stating a domain. So basically the domain is just the one cycle or the unit circle. So I'm going to solve, but I'm not going to do the 2n pi part. Just solve within the domain of one unit circle. So this is kind of weird, right? So it's tangent of 2x. Now what you can do is, I'm thinking of the unit circle. When is your tangent going to be square root of 3? So again, I'm drawing that unit circle. Tangent is going to be tangent of whatever. I'll just call this question mark equals square root of 3. That's when you're going to have sine. Your sine over cosine is going to equal square root of 3. Well, that's going to happen when your sine is square root of 3 over 2 and your cosine is 1 over 2. Or when it's negative square root of 3 over 2 and your cosine is negative 1/2. So these are going to happen at two distinct parts. They're going to happen, nope, sine is your y value, so not right there. It's going to happen, if you do your three spokes right here in the first quadrant, it's going to happen right up here. For when they're positive, the values right there for x is going to be 1/2, and this is going to be square root of 3 over 2. And it's also going to happen when they're both negative in quadrant 3. So, like drawing my spokes, and that's going to be right here, where you have negative 1/2 and negative square root of 3 over 2. So those two values, and basically the angle both there in radians for this first one up here, this one's going to be pi over 6. So I'm going to say tangent. So tangent of pi over 6 is going to equal square root of 3. And then tangent right down here, instead of saying, well, pi over 6 is not correct. I messed up there. So it's not going to happen at tangent of pi over 6. It's going to happen at pi over 3. And down here, it's going to be at 4 pi over 3 equals square root of 3. So you have the two solutions, but we got to actually solve for x in this case. So in this case, it's going to be our 2x is going to equal pi over 3, and your 2x equals 4 pi over 3. Now that means you divide by 2 on both sides, your x is going to be pi over 6, and divide by 2 on both sides, your x is going to be 4 pi over 6, which is 2 pi over 3. Now here's the neat thing. 2x equals pi over 3 plus 2n pi, and 2x equals 4 pi over 3 plus 2n pi. Now, it's because we have this 2x. Now I want to isolate that variable x. So divide everything by 2, you get x equals pi over 6 plus n pi, and x equals, that's going to be 4 pi over 6, or 2 pi over 3 plus n pi. So what values, now we want to start listing out values. Remember, our domain goes from x equals 0 to 2 pi. So for the left equation right here, you have pi over 6, and then adding, the next one would be add a pi to that, so n equals 1. So n equals 0, n equals 1. That's going to be pi over 6 plus 1 pi, so it'll be 7 pi over 6. And then the next one, n equals 2, would be 13 pi over 6. Now let's look at this is the right equation. So the first one's going to be 2 pi over 3, again, n equals 0. And then add another pi to that, that's going to be 5 pi over 3. And then another pi to that, that's going to be 8 pi over 3. Now, the domain is 0 to 2 pi, so no too big, no too big. So our only answers are those 6. So pi over 6, and we can, we can put this in order from ascending order. 2 pi over 3, and then 7 pi over 6, 7 pi over 6, and then, oh boy, and then 5 pi over 3. So those are our 4 answers that satisfy that original equation. All right, solve the next equation here. All right, Again, I want to isolate the trig function. So I'm going to add 3 to both sides. What you're going to get is 4 cosine squared of x equals 3. And I want to divide by 4 on both sides. So when you do that, you're going to cancel out the 4's and get cosine squared of x equals 3/4. Now I want to get rid of the squared. I want to just be cosine, so I'm going to square root both sides. So we're going to get cosine of x. Because I square root, it can be plus or minus. So it's going to be plus or minus the square root of 3 over the square root of 4, which is just 2. So square root of 3 over 2. Now when do you have cosine of x equals square root of 3 over 2? And again, I believe this function is going to ask to be in that domain right there. So I'll draw my unit circle. When's the cosine going to be plus or minus square root of 3 over 2? Those are the x values. And that's going to happen. It's going to happen right here. And it's going to happen right here. And it's going to happen right there and there. So these are the 2 negative x values. These are 2 positive. So that's going to happen at x equals, the first one's going to be pi over 6. Pi over 6. The next one right here is going to be 5 pi over 6. Next one's going to be 7 pi over 6. And the last one is going to be 11 pi over 6. Those are the 4 values where that's going to be true. Now solve this equation. So the first thing here, sine of x, tangent of x equals sine of x. And this is where your algebra skills come into play. And hopefully you can recognize that you play with things. I'm going to subtract sine of x on both sides. And no, these don't cancel out, but what you get a 0 on this side, on the right, and then you get sine of x, tangent of x, minus sine of x. So I want to get all those variables to one side. So that's usually the good call when you have variables on both sides of trig functions. I want to move all the variables to one side. Now what I can do is I can factor out a sine of x from both terms. So I get sine of x equals sine of x times tangent of x minus 1 equals 0. And if you think back, this is similar to factoring. So we have 2 factors. We have sine of x equals 0 and tangent of x minus 1 equals 0. Or another way to write that is tangent of x equals 1. Added 1 to both sides. So I got to solve each of these equations separately. Now the domain is between 0 and 2 pi. So sine of x equals 0. Well, 1 is the sine, that's the y values. Between 0 and 2 pi, that happens at 0, and it happens at pi. And it happens at 2 pi, but that isn't not in our domain. For tangent of x equals 1, well, tangent of x equals 1, going back to my unit circle, sine over cosine happens in quadrant 1 and in quadrant 3. So quadrant 1, that's going to be at pi over 4, and then quadrant 3, that's going to be 5 pi over 4. So our 4 solutions are right there. Last problem of the day. So I can rewrite this cosine of 2x is 1 minus 2 times sine of squared of x plus sine of x equals 0. Alright, now when I have a squared term and then just a sine of x term, I'm thinking quadratics here. So I'm going to rearrange this as negative 2 sine squared of x plus sine of x plus 1 equals 0. Now I don't usually like dealing with a negative coefficient for my first one, for my squared term, so I'm going to multiply or divide let's multiply everything times negative 1 on both sides. 0 times negative 1 is still 0. Basically, it just flips the sign. So you got 2 sine squared of x minus sine of x minus 1 equals 0. Now think of this like a quadratic formula. So like 2x squared minus x minus 1 equals 0, and I asked you to factor. Well, if I asked you to factor, and it's just these x's here, a few different ways. You can do guess and test. So one of these factors would have to be x here, and they have to multiply to negative 1. And one of these coefficients has to be 2. So if you just did some guess and testing, and since I know that's negative, if I set it up like this, it would actually, this is what it factors out to. And I can always check that by multiplying coefficients here, and that's 1, multiplying here, negative 2, and those add up to negative 1, which matches the middle term, the linear term. So I know those are my factors, and you might have, there's a dozen different ways to factor, so I don't care how you do it. So that's how I would factor if it was just the variables. Well, treat the signs the same way. So this is going to factor to 2 sine of x plus 1 times sine of x minus 1 equals 0. and set each of those factors equal to 0. 2 sine of x plus 1 equals 0. So I want to isolate my sine of x. So I'm going to subtract 1 on both sides. 2 sine of x equals negative 1. Divide by 2, I get sine of x equals negative 1/2. For the right factor, sine of x minus 1 equals 0. I'm going to add 1 to both sides, and I get sine of x equals 1. So what are my solutions for both those? And remember my domain. And if you figure those out, when is sine of x equal 1/2? I always like drawing this. So your sine is your y values. When our y value is going to be negative 1/2, well, that's going to be not right there. So negative 1/2 is going to be right there for the sine and right there for the sine. So the two values for sine of negative 1/2 will be at, for this one, it's going to be 7 pi over 6. And for the other one, it's going to be 11 pi over 6. Now, when is sine of x going to equal 1? I'll do that in blue. Sine of x, the y value, that's going to happen right up here when it hits the top. So that will happen at pi over 2. So your three solutions are right here. And that's it.